Alright, so today we're talking chemical reactions. We're just going to dive right into this. So, what is a chemical reaction? It's reaction or change where new substances form. So, one example I have here is burning your food. Another one would be if I combined sodium, which is that gray metal at the bottom, and chlorine, and it made table salt. Chlorine's a yellow gas, so those two very different looking things come together to make the salt that we eat. There are four signs of chemical reactions happening. One of them is a change in temperature. Often things will get really hot or really cold when a reaction takes place. A change in color. For example, we just looked at the table salt where we had a gray color and a yellow color, and they made white table salt. Release of a gas and release of an odor. We have different parts in a chemical reaction, so we have our reactants, which I have in the red at the bottom there. Those are the things on the left. Those are what combine, or those are what are changing, and then we have our products in the blue, and those are what you get at the end. So it's kind of like a math problem. And then we have that little arrow, which just means it yields or produces. It's kind of like an equal sign. This is the important part. What you're really going to want to focus on is the types of chemical reactions. So we have synthesis, which is A plus B makes AB. Decomposition is going to be the opposite of synthesis. You have AB, which turns into A plus B. Single displacement, you have an A by itself and a BC. What ends up happening is that A replaces the B, so now you have B plus AC. Double displacement, AB plus CD makes AD plus CB. So we start with two molecules, and we end with two entirely different molecules. And then finally, combustion. This one's really intimidating to look at, but the important thing is combustion is always some kind of carbon-hydrogen plus oxygen, and it always makes CO2 and H2O. So here's an example of synthesis and a little definition. Synthesis is when two or more atoms or molecules join together to make something larger. I mentioned the chlorine and sodium making table salt, so you see there I have a sodium atom plus a chlorine atom, and they make that NaCl. Decomposition is when something breaks down. You have one big molecule that breaks down into two smaller molecules or atoms. So if I have this CaCO3, that can break down into CaO and CO2. And again, it's an AB turning into an A plus B. Single displacement is pretty interesting. That's when one component switches out for another. So I kind of color-coded this to help you see it. I start with this aluminum all by itself, and it comes over and it switches places with the copper. Double displacement is when two molecules react and you get two entirely new molecules. The example here is really hard to look at. I'm going to see if I can make it a little bit easier to see by drawing my letters. So I have A, B, C, and D. So let's draw my A over. My A is that potassium in that case. Let's put an A here. Okay, my B, right here, that's CrO. Here's my B. My C is that silver. And then my D is that NO. So if you look, we had AB, CD, now we have CVAD. We have two entirely new molecules now, which is kind of neat. And just like that, here you can see what it should look like. When we are looking at combustion, again, this one's kind of interesting. It's where you have a carbon-hydrogen combination plus oxygen, and it always makes CO2 and H2O, and it produces energy. Now, on a test, we're not always going to write the word energy there, because it's kind of a giveaway, but you should be looking for the production of carbon dioxide and water. So now we're going to do a little bit of practice. We're going to look at some different molecules. I'm going to draw on it a little bit to help us see. we're going to figure out what we're looking at. So for this first one, we have Ca, calcium, plus oxygen, and it's going to make CaO. So just go ahead and take a minute and think about what that might be. Yes, that one should be synthesis. That should be a synthesis reaction. How about this one? This one isn't exactly a chemical reaction, but you can kind of figure some things out. We have an egg, which breaks down into a broken egg and a chicken. So there's a chicken inside that egg to begin with. And it's going to be decomposition. You start with one big molecule, and you end with two smaller molecules. I like this one. This is the way I like to think about some reactions. So right here we have this lonely guy. We'll put Lg, lonely guy. And I'm going to put, this is happy guy, because he's got a date. And happy girl, because she has a date. And what you'll notice happens is my two guys switch places. So now my lonely guy has the girl, and the guy who was happy, oh, that should be, look at that. I put G for each. Oh well, should be guy. I'll just fill that in now. This guy is now all by himself because the guy who was lonely stole his girlfriend. You can think about that like this: A plus BC makes AC plus B, because we just changed out one component, so that will be a single displacement. Once again, we're going to do this with people, so we have these two friends and these two friends, and they separate apart. So again, I'll do my letters just because it helps me out. A, B, plus C, D, and that's going to give us A, this fellow. Our B is in the green shirt, let's put a B over here. Purple shirt was a C, and then blue shirt was a D. And that's the same up here, so we have A, here's our B, B, C, C, and D. So you can see we completely have new molecules. And that would be a double displacement. Here's how I really like to think about them. I think it's a fun way to think about these different chemical reactions. I like to imagine synthesis. Two people become a couple. We have that A plus B is C. So person 1 plus person 2, and they start dating. Unfortunately, in decomposition, it doesn't work out and they break up. So now our A's and our B's are separate. Which is sad, but you know, life goes on. Single displacement, one person breaks up your relationship and steals your boyfriend or girlfriend. So we have that A plus BC. All of a sudden A comes in and steals C from B. Now B is all sad and lonely. Double displacement would be if you had a boyfriend or girlfriend and you went on a double date with another couple. Oops, that should be a C. You went on a double date with another couple, and midway through the date, you guys decide you want to swap dates. Which is a little odd, but no judgment. So you can see here we have two entirely new molecules. Completely different. They switched partners halfway through the date. And then combustion, I can't really draw it down here to make it make sense, but I am going to draw the formula for combustion. And I'm just going to read the example to you. So, you get into a fight with your boyfriend or girlfriend, and you burn their stuff. And burning things always requires these two, and always produces CO2, oh, it should be a plus, and H2O, with, you know, energy in there. This is how I like to think about them. I think it's a fun way to think about them, and I think it's a pretty memorable way to look at our different chemical reactions.